Alright, for example 2, consider the following system of equations. 4x plus 3y is equal to 0, and 8x minus 9y is equal to 5. Solve and verify the system using the method of substitution. Well, it doesn't matter which one of these that we isolate. So in this case, I'm going to take equation 1 and I'm going to isolate y. So I'm going to state that for equation 1, if 4x plus 3y is equal to 0, then 3y would equal negative 4x, and y would equal negative 4 over 3x. Now I'm going to take that and put it into equation 2. And I'm going to say, well, for equation 2, I'm going to have 8x minus 9 times negative 4 over 3x is going to equal 5. Or 8x, negative 9 times negative 4 is going to be 36, divided by 3 is going to be plus 12x is equal to 5. So 20x equals 5, or x is going to equal 1 over 4. Once I have that, I'm going to put it back into my original equation, and I'm going to state that if y is equal to negative 4 over 3 times 1 over 4, then y is going to equal negative 1 over 3. And I have my solution. 1 over 4 and negative 1 over 3. I should really quickly verify this just to make sure that works. You can check your solution using your graphing calculator as well, and on your graphing calculator it's going to say 0.25 for x and negative 0.333333 for y, but we're just going to verify this real quick algebraically because it's something you should be able to do anyways, and say that if I have 4 times 1 over 4 plus 3 times negative 1 over 3 equals 0, well, that's going to be 1 minus 1 is equal to 0, 0 equals 0, and it definitely works for this equation. For equation 2, if I have 8 times 1 over 4 minus 9 times negative 1 over 3 equals 5, well, 8 times 1 over 4 is going to give me 2. Negative 9 times negative 1 over 3 is going to give me positive 3. 5 equals 5, and my solutions work. For example 3, consider the following system of equations. So if I have 5 bracket 2a minus 3 plus b equals 5, and 6a minus 2 bracket b minus 4 is equal to 20, and it wants us to solve this using one of the systems, then I'm going to, before I get too far, simplify both these equations. I'm going to state that, well, for this one, it's actually going to be 10a minus 15 plus b is equal to 5, or 10a plus b is equal to 20. For my second equation, I'm going to say that 6a minus 2b plus 8 is equal to 20, or 6a minus 2b is equal to 12. Now, I can choose which one I want to isolate in. Well, obviously, it's easier to isolate b for equation 1. So if 10a plus b is equal to 20, then b is going to equal negative 10a plus 20. I go to equation 2, and if I have 6a minus 2b, well, it's going to be minus 2 times negative 10a plus 20 is equal to 12. Then 6a minus, sorry, not minus, plus 20a minus 40 is equal to 12. Or 26a is equal to 52, and a is just going to equal 2. I go back to equation 1, and b is equal to negative 10 times 2 plus 20. B is equal to negative 20 plus 20. B is equal to 0. So in this case, I have a is equal to 2, b is equal to 0. Now we need to verify in its original form that this solution works in both cases. So I'm going to start with equation 1, and I'm going to say that 5 bracket 2 times 2 minus 3 plus 0 is equal to 5. 5 times 4 minus 3 is equal to 5. 5 times 1 is equal to 5. This one works. For equation 2, if I have 6 times 2 minus 2 times 0 minus 4 is equal to 20. 12 minus 2 times negative 2 is equal to 20. 12, sorry, minus 4 is equal to 20. 12 plus 8 is equal to 20. 20 is equal to 20. And my solution works in both occasions. All right. For the last one, now this one is a little bit more complex than what you're going to see on your test or things for this year, but it's a good example of how to do this process because you can always do it multiple times. So what we see here is right from the get-go, I can see that I have 3 equations, I have 3 different variables, but one of them is isolated before I've even started. So that means that I have equation 1, I have equation 2, and I have equation 3. Now, what I'm going to do is I'm going to substitute equation 2 into equation 1 right from the get-go. And I'm going to say that for equation 1, I can state that equation 1 is actually 4x minus 3y minus 5 times 2x is equal to 6, which means I have 4x minus 3y minus 10x is equal to 6, or negative 3y minus 6x is equal to 6. Well, since I'm already here, I might as well isolate for one of the variables in this one, and in this case, I'm going to isolate for y. So I'm going to say that negative 3y is equal to 6x plus 6, or y is equal to negative 2x minus 2. I'm going to put that value of y into equation 3. Negative 2x plus 5, negative 2x minus 2 minus 14 is equal to 0. And now I have my first equation with just one variable. Negative 2x minus 10x minus 10 minus 14 is equal to 0. Negative 12x, well, negative 10 and negative 14 is going to be negative 24. When I move it across, it's going to be positive 24, not 20. Or x is equal to negative 2. Now, I can take my value of x and put it back into equation 1. Y is equal to negative 2 times negative 2 minus 2. Y is equal to 4 minus 2. Y is equal to positive 2. And I can put my value for x back into equation 2. If z is equal to 2 times negative 2, z is going to equal negative 4. And there's my solution. X equals negative 2, y is equal to 2, and z is equal to negative 4.